Hello everyone. This video will be going over rational exponents. Okay, so getting started, first we're going to go over the idea of what a square root is. Okay, now the square root of any number is the value that can be multiplied by itself to give you the initial value under the radical symbol. Okay, and that number under the radical symbol is called your radicand. Okay, now the value on the outside of the radical symbol, that's called your index, and we'll get to the meaning for that in a little bit. And the symbol itself is just the radical symbol. Alright, so let's say, for example, if you wanted to find the square root of 25. Okay, so we know that 25 is equal to 5 times 5. And we can also see that 25 is equal to negative 5 times negative 5. Okay, now since 5 times 5 and negative 5 times negative 5 equals 25, we know that square root of 25 can equal 5 or negative 5. In other words, you may see it as plus or minus 5, either positive or negative 5. Alright, so let's go ahead and do another example. Say square root of 1. Okay, so we can see that 1 is equal to 1 times 1. And we also know 1 is equal to negative 1 times negative 1. So we know that square root of 1 is equal to positive or negative 1. Alright, so let's say if we have our square root of 49. And I want you to go ahead and take a few seconds to do this one. Alright, so assuming you have this one done, we know that 49 is equal to 7 times 7. And 49 is equal to negative 7 times negative 7. So that means square root of 49, move that up a little, is equal to positive or negative 7. Alright. Okay, so let's go on to our next portion of the video. Okay, so let's say that if we let the variable a represent a real number. Okay, so if we have the square root of a, that's what we call a principal square root. Now, if you have the negative of that square root of a, that's of course called the negative square root. Or in other words, negative square root of a is just the same as saying negative 1 times that square root of a. Alright, so for example, if we had negative square root of 49, that would just be the same as saying negative 1 times square root of 49. Right? Now, to really get an understanding of the type of square roots you're going to be seeing, we're going to start with, I guess you could say, two kinds. Okay, so numbers like 1, 4, 9, 16, 25, 36, 49, 64, etc. are all called perfect squares. Okay, so why are they called perfect squares? Is because if you look at 1, that's 1 times 1, or negative 1 times negative 1. 4 is 2 times 2, or negative 2 times negative 2. 9 is 3 times 3, or negative 3 times negative 3. 16 is 4 times 4, or negative 4 times negative 4. So they're called perfect squares whenever you have an integer that can multiply to itself to give you that value. Okay. Now, if you have the square root of those perfect squares, then your answer will be a rational number, what we call a rational number. Okay, so if you have the square root of a, where a could be any one of those perfect squares, then the square root is a rational number. Okay, so that's how you know you have a rational number, is when you can get the square root of it and you still have a number that's not a decimal or some never-ending number. Okay. Now, if your a value is not a perfect square, if it's not one of those numbers, then your answer will be an irrational number. If a is not a perfect square, then the square root of a is an irrational number. Okay, so for example, if you have the square root of 3, or the square root of 8, or the square root of 21, or the square root of 35, any number that's not a perfect square, if you take that square root, you'd get an irrational number. Or basically, an irrational number is just a decimal that could go on forever. All right. Now, if we know that a is a negative number, then the square root of a is not a real number. All right. So for example, if you have square root of negative 4. Okay, remember, with the square root, we'd have to find a number that multiplies to itself to give us our radicand. So you can't say 2 times 2 because that's positive 4. You can't say negative 2 times negative 2 because that's positive 4. So this actually has no real solution. Now, it does have a solution. You just don't have a real number solution. Okay, that will go into what we call complex solution or complex answers or complex values, and we're going to get into that later. All right. Okay. Now, if we have a square root of a, then it's automatically assumed that your index is 2. So when there's no index, you automatically know it's a 2. Okay, so for example, if you have square root of 100, then that's the same as an index of 2 of square root of 100. Okay. Now what if your index is a 3? So if you have an index of 3, we call that a cube root of a. Okay, same. So if you have an index of 4, that's a 4th root of a. Same with index of 5. That's your 5th root of a. And it keeps on going and going and going. All the way, let's say, that can be an nth root of a. Okay, so the same idea behind a square root, meaning any two numbers that multiply to its, or any number that multiplies to itself twice to give you 100. Same thing for a cube root. Any number that multiplies to itself 3 times to give you whatever a is. Same with a 4th root. Any number that multiplies to itself 4 times to give you that a value. Same with the 5th root. Any number that multiply to itself 5 times to give you that a value. All right, so let's say, for example, if we wanted to solve, say for problem A, square root of 121, say for problem B, cube root of 8, and let's say for problem C, the cube root of negative 8. Okay, so we see for problem A, square root of 121, we automatically know that, and there's no index, it's automatically a 2 there. So what two numbers multiply to give you, well, multiply to itself to give you 121? It's either positive 11 or negative 11. Since 11 times 11 is 121, and negative 11 times negative 11 is 121. Okay, same thing with B. Okay, so if you look at problem B, you have the cube root of 8. We're really just asking what number multiplied to itself in this case 3 times, will give you 8. Okay, now since we know that 2 times 2 times 2 equals 8, that means that the cube root of 8 is equal to 2. Okay, now if we look at problem C, okay, now if you remember, when you have a square root, that number can't be negative. But when you have a cube root, your radicand can be negative and you could have an answer. Okay, so if you have the cube root of negative 8, again, we're going to ask what number multiplied to itself 3 times will give you negative 8. Straight up the question mark there. And once again, if you look at the fact that negative 2 times negative 2 times negative 2 equals negative 8, that means that the cube root of negative 8 equals negative 2. Alright. Okay, so let's go to our general idea. Okay, so in general, okay, and again, we're looking for our nth root of whatever our radicand is. So for the nth root of a, if the index is odd, then negative radicands for a root function can have a negative solution. Okay, so for example, like we just did, the cube root of negative 8, which is negative 2. Now, if your index is even, remember the number outside here, that's your index. If the index is even, your solution exists if and only if, that little if and only if, you may run across that in the occasional math book. If and only if the radicand is positive. Alright, so let's say, for example, if we wanted to solve, say for problem A, the square root of negative 16. For problem B, the fifth root of negative 32. And for problem C, the cube root of negative 27. Okay, so for problem A, we know that the square root of negative 16, when there's no index, we automatically assume that there's a 2. Okay, which means we have an even index. Okay, we have an even index, your radicand cannot be negative. So you have no real solution. Okay, now for problem B, say the fifth root of negative 32. Now remember, this index is odd. So your radicand can be negative, and you'll be okay. You could have a negative solution or positive solution depending on what it is. Okay, so we know that negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is equal to negative 32. Okay, so we know that negative 2 multiplied to itself 5 times will give us negative 32. So that lets us know that the fifth root of negative 32 is negative 2. Alright, problem C, we have the cube root of negative 27. We know that negative 3 times negative 3 times negative 3 equals negative 27. So we know the cube root of negative 27 is equal to negative 3. Alright. Okay, so we will continue this lesson on the next video.